Homework 10, Quadratic Functions, Video 7. In the previous video, we discussed that a parabola can have a maximum or a minimum, depending upon if the parabola opens upward, has a minimum, or downward, has a maximum, and that maximum or minimum can be interpreted contextually if our function is modeling a real-world situation. So here's an example similar to one of your homework problems. It's actually similar to two of them. A decathlete launches a shot put at an angle of 65 degrees. Don't worry about the 65 degrees, we won't be using that. The height off of the ground, f of x, can be calculated by the function f of x equals negative 0.03x squared plus 2.1x plus 6.4, where x is the horizontal distance traveled by the shot put. Now I haven't asked a question yet, but I want to make sure you understand what the x and the function are measuring. The x is measuring how far the shot put is traveled. By the way, this upside down parabola is the path of the shot put. When objects fly through the air, they always follow a parabola. It has to do with physics and gravity. But I digress. The x is measuring how far the shot put has traveled in the horizontal direction, and f of x is measuring how far in the air the shot put is at that moment in time. So as the shot put travels horizontally, its vertical distance increases and then starts decreasing thanks to gravity until it hits the ground. Now there's all kinds of questions I can ask you, but I'm going to do this problem a little bit in reverse. Instead of asking you anything, let's find everything about this parabola and then see what it means in the context of the situation. What do I mean everything about this parabola? Well, the points of interest. The vertex, the x-intercept, and the y-intercept. So let's go ahead and calculate those, and then we'll figure out what they have to do with this shot put traveling through the air. Let's start with the vertex. Because this function is in general form, ax squared plus bx plus c, we can just use the formula for the vertex. The formula was x equals negative b over 2a, and then we insert that into the function to find the y-coordinate. So let's figure out the x-coordinate of the vertex. What is the b in this quadratic function? 2.1. So it picks up a negative, and downstairs we do 2 times a. What is the a in this quadratic function? Negative 0.03. You can put this in a calculator, but I think I can do it without. The top stays negative 2.1, but if I double the denominator, I get negative 0.06. Negative divided by negative is positive, so I don't have to worry about that. And I want to show you a dirty trick for dividing decimals. You can move both decimals in the same direction, the same distance, and it won't change the answer. So for example, I'm going to move both decimals to the right 2. Now I know there's only one decimal place on top, so I'll insert a 0. Negative divided by negative is positive, so those are gone. The top is 210 now, and the bottom is 6. And I'm pretty sure that 210 divided by 6 is 35. Don't try to be fancy and impress me in the homework or test. Get out the calculator. I'm just doing it so I don't have to reach over and grab my calculator. So the x-coordinate is 35. To find the y-coordinate, we just have to substitute 35 into the function. Negative 0.03 times 35 squared plus 2.1 times 35 plus 6.4. And although with enough time I could crank that out without a calculator, it would waste too much time. So I'm just going to use my calculator. 35 squared times negative 0.03 plus 2.1 times 35 plus 6.4. And we get 43.15. So the coordinates of the vertex are 35, 43.15. We'll interpret that in a moment, but let's find the other stuff, the intercepts. The y-intercept is pretty easy. All we have to do is insert 0 into the function. We don't need a calculator. 0 will kill this term, and the only one left will be 6.4. So the y-intercept is We'll just say 6.4, although technically it's an ordered pair, 0, 6.4. What about the x-intercepts? Well, for the x-intercepts, we have to solve the function equal to 0. And this function looks like I'm going to have to get out the quadratic formula. But I'm going to show you a couple of tricks. Now, you can use the quadratic formula on this directly without any tricks. But, well, let me get it set up and I'll show you. We need to solve the function equal to 0. So negative 0.03x squared plus 2.1x plus 6.4 is equal to 0. Don't get me wrong, we can get out the quadratic formula right now. But there are two things about this that I don't like. Number one, the negative in the front. And number two, all the decimals. I can fix both of those in one move. I can move all the decimals 2 places to the right if I multiply everything by 10. Excuse me, by 100. Why 2 places? That would kill this decimal and those. But if I multiply by negative, it'll change this positive. So I'm going to do myself a favor, and you don't have to do this. You can do the quadratic formula on all the numbers that you see there. But I'm going to make, there I go with 10 again. I'm going to make the conscious effort to multiply everything by negative 100 to fix the things that I don't like. That'll fix this leading negative, and that'll kill all the decimals. So change all the signs and move the decimal 2 places to the right. 3x squared minus 210x plus 640. I know the numbers are larger, but at least they're not decimals. So let's get out the quadratic formula. And if you don't want to do that move, and I understand, then go ahead and do the quadratic formula on the original, and at the very end we should get the same answers. So without jumping through all the hoops, negative b, so negative of negative 210, so 210, plus or minus the square root of b squared, so negative 210 squared, minus 4ac, so minus 4 times 3 times 640, over 2 times a, so over 2 times 3. So 210 plus or minus, and the denominator is 6. Under the square root, we're going to get a pretty large number, 210 squared. Don't need a negative there because it's going to disappear anyway. Minus 4 times 3 times 640 is 36,420. Now, this homework question will ask for your answer rounded to so many decimal places. Why is that important? If I need a decimal answer, there's no need to try to simplify anything. Just put it directly into your calculator. Now this has 2 answers, one with a plus, one with a minus. So let me start by putting in the problem with the plus in front of the square root, parentheses 210 plus the square root of 36,420, close parentheses, divided by 6. And I get about 66, let's just take it to 1 decimal place, 66.8. And if I do the same problem with subtraction instead of addition, then I'll get, that can't be right. Something went astray. The reason I said that can't be right is because the other answer I got was 3.2. Now, why did I say that can't be right? Where's the other x-intercept? Should be back over here, should be negative. So now I have to pause and figure out where I went wrong. Can't pause the video because then it'll start a new one. Make sure I wrote the problem down correctly. I did. Negative 0.03x squared plus 2.1x plus 6.4. I'm guessing I might have made a mistake in the transition from here to here, and I did. I just caught it. When I said I was going to, this is the danger of doing trickery like this. When I said I'm going to multiply by negative 100 to change this to positive and kill all the decimals, I also said that all the signs are going to change, and I didn't change this one. Shame on me. Oops, I'll leave that alone for a second. So that's going to change the number under the square root. I can hear some of y'all snickering. See, if you hadn't tried to be fancy, you wouldn't have made that mistake. So give me 1 second to fix the problem. The number under my square root would be 51,780. If you did this without doing all the shenanigans, you'll get a number that looks about the same but a decimal somewhere else. And now, if I put the problem in correctly, well, I put it in correctly last time, it was just the wrong problem. Okay. 72.9, and this one should come out negative. Well, it would help if I actually put the minus sign in. Negative 2.9. There's a lesson to be learned here. Using common sense and seeing the big picture can help you catch mistakes. When I was planning on discussing the x-intercepts, I thought about bringing up the fact that normally we got 2 x-intercepts and there's only 1. Where's the other one? If the shot put went backwards and continued, it would have a negative x-intercept. So when I didn't get a negative over there, I was like, something's wrong. So thinking about a problem in advance can help you catch mistakes that you might make. There's nothing wrong with making mistakes unless you don't learn from them. And I'm speaking specifically to one of you. You know who you are. All right, so let's label our x-intercept. This x-intercept is 72.9. And if time went backwards and the shot put completed its path over here, it would have another x-intercept of negative 2.9. So what do all these numbers mean in the context of this problem? Well, let's start with the vertex. What's so special about that point? Well, the vertex represents a maximum. A maximum what? Maximum distance traveled? No, maximum height. So from this vertex, we can say 2 things. At 35 feet traveled, because remember, the x is measuring how far it's traveled horizontally. The shot put attains a maximum height of 43.15 feet. Now, of course, in the Olympics or in any other event where you're throwing a shot put, your score is not gauged on how high it goes in the air, but rather how far it travels. And that's what this x-intercept represents. So this x-intercept means that the shot put traveled The shot put traveled 72.9 feet. I don't know if that's good or bad. I just know that if I threw it, it wouldn't go anywhere near that. So what does this y-intercept represent? This y-intercept represents how far the shot put was off the ground when it was released. So this is the height off the ground when the shot put was released. The intention of this was to talk about the vertex, but I wanted to show you that the intercepts also had meaning in the context of the problem. Does this mean that the shot putter was 6.4 feet tall or about 6'5"? Not necessarily, because normally when they release a shot put, it's like this, so he might actually be a little bit shorter. All right, we're going to take a look at one more example where finding the maximum or minimum of a quadratic function has a meaning in a context.